When building a frame, the choice of pipes is very important. Today we'll look at two options: hot rolled welded pipe and cold rolled seamless pipe. The first main difference between them is their diameters. These two pipes are both supposedly 28 millimeters in diameter, but if you take the cold rolled pipe, its diameter is exactly 28. If you take the welded pipe, its diameter will be 27.3. The first problem that can occur if you choose the wrong pipe depends on where you will be bending the pipes. If you have a pipe bender, you need to know which pipe it is designed for. For example, if you take this pipe, it has a smaller diameter. If the pipe bender is designed exactly for 28 millimeters, the pipe will simply deform during bending. A pipe bender for a 28 millimeter pipe, and if you put a piece of pipe here, it fits tightly, it doesn't wobble up and down. If you take a welded pipe, you'll already see a gap. Accordingly, the bend will no longer be even and correct. Here are two identical pipes. This pipe is after bending in cross-section. You can notice that it is slightly deformed. Here the hole is more oval, and here it is perfectly round. I'll tell you a couple of nuances about the frame. The first question I wanted to solve is where these pipes will be welded. A small nuance: the opposed engines have a gearbox, and this whole part is just for mounting the gearbox. So you can't weld a pipe anywhere on this part, only this section is available for welding. If you weld a pipe here, then on this side it will end up right here. That's a large distance for the pipe. So here's the mount, and this whole section will be sticking out. I've seen such frames many times on the internet. I don't like that kind of design. So my first task was to make sure there wasn't such a large gap here. At the same time, I needed to keep these two pipes parallel. I decided to make a bend at the end of the pipe. That way I kept the two pipes parallel and was able to weld the pipe further on the left side. So I think this is the most optimal solution if you don't want to leave a large gap here. Now I'll try to explain how to weld the frame so that the wheel is centered. For this you'll need a hub and a reducer cover with a spline part. You need to mark the center on the hub. I have the hub, 6.5 millimeters. The center is 3.25. Next, put on the spline part, and from this part of the reducer cover, you need to measure from the plane to the center. To do this, take some straight tool, like a square or a level, and place it here. And use a measuring tool, like a tape measure or a ruler. Measure towards the center. For me, the hub measures 14.5. Now, on the jig, the right dropout needs to be set 14.5 from the center. To do this, you need to mount it on the axle, set the required distance, and secure it together with the reducer cover. And find out what kind of spacer is needed here. It's needed here to clamp the axle and simply work with the frame. On the other side, there's also a spacer, it just serves as a stop. When it came to these tubes, I decided to use part of a standard frame because my tube bender only makes sharp angles. That is, it has a very small radius. Here's another frame where the tubes were bent using my tube bender. I don't know how well you can see it on camera, but here the angles are sharper than if you use, for example, a standard part of the frame. Even if you line it up along the bend, you can notice how smooth the curve is here before welding the pipe. So you definitely need to bevel the edges, and it's even better to leave a gap. You should tack the pipe in 4 places opposite each other. This way, during the welding process, the pipe won't get pulled to one side, and everything will stay in place. And you'll end up with a straight pipe. The tack welds need to be cleaned up a bit, as they don't allow for a good weld. If you weld over them, you won't be able to properly heat the spot where the tack is, so they need to be cleaned, but leave a thin layer of the tack weld. After welding, you now need to clean up the seam. And to make everything even and neat, you shouldn't make constant back and forth movements while cleaning. You need to clean the seam itself. Otherwise, you won't get an even finish. From the outside, it will look something like this in a kind of wave. When cleaning, you need to watch carefully. Then the best option is this. It's best to finish everything off using the good old method. Here, the seam area is all even, everything looks neat and tidy. First, you need to tack it in this direction. Choose the position you like best, because the other side will be aligned based on this pipe. Now I will tack the right side at the front and back. You need to make sure that these pipes are aligned with each other when assembling the frame. For example, you can use the rear axis to check that these two pipes are the same without any distortion, so that everything is straight. Usually the springs are welded exactly to the end of the spacer part of the pipe. But I want the distance from the wheel to this pipe to be minimal, but the brackets don't allow me to mount it that way. So the mounts themselves will be here and the pipe will be lower. The distance between the threads on the seat is 18 centimeters, and here the length from edge to edge of the pipe is also 18 centimeters. But because there's a gearbox here, the right side is wider from the center than the left side. This could have been compensated for by making the left side as thick as the right, but I wanted to keep all the gaps to a minimum. The brake disc will be here and it will be right up against the frame. If the width here is 14.5, then here it turns out to be 12 centimeters. Accordingly, there are differences here as well. If you measure from the center of the frame to the center of the tube, the left side is 10 centimeters at the spring mounts, while the right side is 11 centimeters. That's why these mounts will simply be cut to fit the tube, meaning on this side the cutout will be deeper so that the mount sits further in, while on this side it will be shallower if one side is wider. Accordingly, this tube has some issues with centering. If you install it in the center, you can notice that here it sits a bit lower. All of this, in principle, can be compensated for simply by installing it evenly. Ultimately, it won't be noticeable. Personally, I don't see anything particularly wrong with that. Now I'll explain how you can fit the tube. First, you need to determine what length you need to cut it to. This recess on the tube is 10 millimeters. To do this, you need to place a ruler and visually add a centimeter on top. An overlap, the length of the tube I need is 20 centimeters. So this is the tube. And when I make these two recesses on both sides, it will just fit tightly in there. Now this centimeter needs to be marked at the end of the tube. Take a ruler and from the edge of the tube mark 1 centimeter. Now you need to cut out triangles like this, leaving about a centimeter between one cut and the other. Of course, this is if the tube diameter is 2.8. If the diameter is larger, then all the measurements will be larger accordingly. And repeat the same thing on the opposite side. After everything is cut out, you need to give it a rounded shape. You can do this on a grinder. While grinding, you can take another piece of pipe and simply hold it up to check how tightly everything fits and adjust each side as needed. You can make sure your work is even by taking the part of the pipe you've shaped and pressing it against the other pipe. After that, take an angle piece and just check if there's anywhere you might need to trim a bit more. Here the pipe is ready, the bevel has been made. The bigger the bevel, the better, the depth of penetration. And now the vertical pipe has already been tacked in place. If you have the opportunity, of course, it's better to use a laser as a reference. That way it will be faster and easier to find the center. I've shared everything I thought was necessary. Later on, the back part of the frame will also be sheathed. There will be some at the front as well. Some sheets will be added in the front too. I don't know which ones yet. I haven't thought about that, and honestly I don't need it right now. Unfortunately, the front part of the frame was made before I started filming the video. You can subscribe to my channel and follow the updates. For this motorcycle, I think, if everything works out, there will be videos on building the fork, wheels, engine, and everything else. So stay tuned for the next videos.